Hi, everyone. Today's lesson is on sum and difference formulas. So I want to start off with a quick review on our Pythagorean identities that we talked about in the previous lesson. And just quickly, starting off, this is a radius. And if this is my unit circle and this is 1, I'm going to make a right triangle here where this value being my x value is cosine, this value being my y value is sine. And if I were going to cosine of x and sine of x, and if I was using the Pythagorean theorem, let's say, I would say sine squared of x plus cosine squared of x is equal to 1. And that was the first Pythagorean identity that we talked about. And I asked you to remember this because it's really important. And of course, that has 3 parts to it, or 2 other parts as well, that are sort of derivatives of this. Meaning, if I were to isolate the sine, you would get sine squared of x is equal to 1 minus cosine squared of x. And if I isolated the cosine, I also could get cosine squared of x is equal to 1 minus sine squared of x. And in addition to that, we also talked about taking this right here, this being a difference of 2 squares, and saying, well, I could also say cosine squared of x is equal to 1 plus sine of x times 1 minus sine of x, because that is a difference of 2 squares. So we had actually 4, because this also is a difference of 2 squares. We had 4 different variations of this one Pythagorean identity. In addition to this one Pythagorean identity, if I was to take this identity and I was to divide it by sine or cosine, meaning I were to take sine squared of x plus cosine squared of x equals 1, and I were to divide the entire thing by, let's say, sine squared of x, every term got divided by that. I would have sine squared of x divided by sine squared of x plus cosine squared of x divided by sine squared of x is equal to 1 divided by sine squared of x. And given that, that's going to be 1. This is cotangent squared of x, and that equals 1 divided by sine squared of x is cosecant squared of x squared x. And so this is my second Pythagorean identity. And then I said, well, with this second Pythagorean identity, let's rewrite that into other variations, meaning I could isolate the 1 and it would be cosecant squared of x minus cotangent squared of x. Or I could say, isolating the cotangent squared of x, that would give me cosecant squared of x minus 1. In addition to those 2, these also are differences of 2 squares. This would be cosecant of x plus 1 and cosecant of x minus 1. And this one would be cosecant of x plus cotangent of x and cosecant of x minus cotangent of x. So each one of these identities has 4 other parts to it. And then the last identity that I asked you to remember was another derivative of the original one. Instead of dividing by sine squared of x, I would divide by cosine squared of x. And in doing that, I'd have sine squared of x divided by cosine squared of x, which is tangent squared of x, plus cosine squared of x divided by cosine squared of x is 1. And then 1 divided by cosine squared of x, which is secant squared of x. So I had my 3 derivatives of my graph, and all based on this, this one right here, which was our first Pythagorean identity, which is sine squared of x plus cosine squared of x equals 1. And so each one of these has their own derivatives of it. And just know that there's so many different variations that you kind of just got to be on the lookout for what to use where and when. So we started off with a warm-up of Pythagorean identities. So sine squared plus, this was cosine squared of x, all right? Or you could say cosine squared of x is equal to 1 minus sine squared of x, or this would be cosine squared of x is 1 minus sine squared of x. For these, this was 1 plus tangent squared of x is equal to secant squared of x. Secant squared of x minus tangent squared of x equals 1. Or I could say 1 minus, oh, well, I guess I could say 1 minus, there's so many different things you could do. I could say tangent squared of x minus secant squared of x is equal to, does that make what, -1? Oh, that does. Yeah, okay, and then this one right here is 1 plus cotangent squared of x, and then this would be, or I could say cotangent squared of x minus cosecant squared of x is 1, or cotangent squared of x minus cosecant squared of x is equal, cotangent squared of x minus cosecant squared of x also is -1. Cotangent squared of, yeah, that's right. Okay, so simplify the following trig equation or expressions. So we know that, reiterating back to sine and cosine, we know that, just reviewing, that sine, when you're reflecting your graph around the y-axis, sine is going to be negative. We also know that cosine is going to be positive. Well, sine over cosine is tangent. So that means if I have a negative divided by a positive, that's going to be a negative. What that does also is cotangent of x is the reciprocal property of tangent. So that means if tangent is negative, so is cotangent. So this is saying this is going to be negative cotangent of theta over, and cosecant, and this is an arrow, not because it's an expression, there's no equal signs. Cosecant is reciprocal of sine, and we know sine's negative, so that means cosecant is also negative. Now, two negatives make positive, and so this is going to cancel in to be a positive. Now I'm going to rewrite this because I'm trying to simplify this expression, and so cotangent is actually cosine of theta over sine of theta, okay? See this line right here? That means divide. So we're dividing, big line there, dividing cosecant, which is 1 over sine of theta. And so using arrows, because there's no equal sign in an expression, we're going to rewrite this as cosine of theta over sine of theta times, because division is actually multiplying by the reciprocal. So this will be times, flip this over, sine of theta over 1. And then my sine, of course, will cancel like that. They'll cancel out and make 1. And so I'll just end up having cosine of theta. And so that's my answer because I'm just simplifying. Now, for the problem here on the right, this one's a little bit more tricky than you would originally think. This here is a quadratic. And some people will take out the sign and they'll use like U substitution. You don't have to, you can, you don't have to. So what I'm going to do is not do it, and then you can decide if you want to or not. This right here, what multiplies to be sine squared? See the sine and sine? See how these are the same sign? These aren't. So that is, while cosine is a quadratic, this trinomial here is not part of a quadratic, okay? Whereas this is. So 2, you would say 2 sine of theta, and this is sine of theta. I know it uses t, but I'm going to use theta. And this is sine of theta, okay? Let me rewrite that. Sine of theta. So 2 sine of theta times sine of theta makes 2 sine squared of theta. And for 3, I'm probably going to make this a positive 3 here and a -1, because when I check to make 3, when I check the insides and the outsides, I'm going to get 2 sine of theta times -1 is -2. But then 3 sine of 3 times sine of theta, so that's 3 sine of theta minus 2 sine of theta is 1. See the 1 here? 1 sine of theta. So this is right so far. Now what I have here is an interesting thing. It looks like this right here, remember from our Pythagorean identity right here? See this one? 1 minus cosine. Anyway, that's sine squared. That right there is sine squared. So I'm going to start off by saying that's sine squared of theta minus sine of theta. And so what I'm going to do next is I'm going to actually factor out from here a sine theta. So I'm going to say, well, I know I can take on the denominator a sine of theta out. So then I have 1 sine of theta left minus 1. And what that means, okay, so I just simplified that. This is exactly the same as this, and those are going to divide out. So what's left is 2 sine theta plus 3 all over this value that's left, all over sine of theta. So we're done. That's as simplified as you can get. You can't break into the sign because this is a quantity, and you can't touch that. That's a quantity as a together. So today is all about super fun stuff like sum and difference formulas, okay? Now, these are them. Now, while I don't want to say you don't have to memorize these, you kind of do need to know how to do these, and you need to know these mostly by memorization. And so what I would do here is you need to look at some commonalities here. Sine of the quantity a plus b. Well, that's going to be sine of A and cosine of B. See how these are different? But I'm using the same letter, A and B here. Sine is the same. So if that's a positive value, so is that. And then I have cosine of A, sine B. Okay? Whereas if this is positive here, that's positive. And so in my mind, I always think, well, sine is the same. So if this is positive, that's positive. See sine here? If this is negative here, then this is negative in between. For sine, it always goes sine, cosine, and you could even rewrite these like this and put these in different order. Put this sine B, cosine A, and I actually do that a lot. Just remember, sine has the same sign, so plus, plus, minus, minus. Okay, so those are the sine formulas for sums and differences. For cosine, a little bit different. Cosine goes cosine, cosine, sine, sine. Here's cosine, 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 sine, sine. All right. And with those two formulas for sum and difference, see how this is a plus, this is a minus. And these are not the same. Cosine is not the same. Sine's the same, but cosine isn't. And then see how this is a minus? Okay, that's a plus. And so you've got a minus here, plus here, but it still goes cosine, cosine. Then we have tangent. Now, tangent's just different. Tangent's usually sine over cosine. So I am just saying one option for tangent of the quantity a plus b is to take sine, do that whole thing, and take cosine, do that whole thing, and then you have sine over cosine. Just saying, that is an option, all right? Okay, that being said, this is a lot easier and a little bit less work. Tangent, no, look at this. If this is a positive here, the top is a plus, the bottom is a minus. If this is a minus, the top is a minus, but the bottom is a plus. And you're adding tangent A plus tangent B, and then 1 minus the product of them. So what you should do is kind of look at these and then rewrite them and practice, because you need to memorize them pretty much. For sine, what I remember is this is going to be sine of A, cosine of B, and sine has the same sign, so that's going to be plus. And then I rewrite these differently. I say sine, if I used A, now I'm using sine B. If I used cosine B, this is going to be cosine A. For this one, this is the difference, so that's going to be, again, sine A, cosine B, and because this is a minus, that'll be a minus. So now I used A already, so now it'll be sine of B, and then cosine of A. For cosine, remember cosine goes cosine, cosine. So this will be cosine A, cosine B. And if this is plus, cosine's different, so that's minus. Whereas sine has the same sign. So see how that's minus? This is also minus. So cosine's the opposite. And so that'll be minus sine A, sine B. Now this one, again, cosine goes cosine, cosine. So this will be cosine A, cosine B, and then this minus changes to a plus, and that'll be sine A and then sine B. And then lastly, these two, for tangent, it's tangent A, because that's a plus, this will be plus on top, tangent of B, and then it's the divided by 1, sign changes, minus the product. So whatever tangent of A times tangent of B is. And the last one is very similar to this, but the changing signs. So this will be tangent A minus tangent B. You guys see how many emails I get? Okay, over, and this will be 1 plus tangent of A, tangent of B. Okay, so you do need to spend some time and try to remember and try to memorize those. So when are we going to use that? What does that have anything to do with anything? Okay, so we're going to figure that out right now. See this? Our first lesson, sine of 105. Your job is to find sine of 105, and I want you to expand it using what we just learned, either a sum or difference formula. And so you're really asking yourself, what can I add or subtract that's going to add up to be sine 105 degrees? So think about that. And then you ask yourself, well, I think I can say that's going to be sine of, okay, let me rewrite that. That's going to be sine of 60 degrees plus 45 degrees. Okay. And remember, this whole chapter is all about proofs. We like proofs. Proofs are fun. Some proofs are more fun than others. But we already know what this is. We know that sine of 105, and let's use your calculator, pick up your calculator and make sure you're in degrees on your calculator and figure out what sine of 105 is. So I'm going to use sine of 105. I get 0.9659. So sine of 105 degrees is about 0.9659. That's what I want to prove. I already know what my answer is going to look like. It's that, but I need to prove that. Okay. So the first thing we're going to do is we're going to expand this. Okay. So we know that, see, right here, it's right here, but sine. So we're going to say this is sine of 60, right? Cosine of 45. Sine is the same sign. So if that's plus, so is this. And then because I have already used 60, now I'm going to use sine of 45 degrees. And now it's going to be times cosine of 60. And so you just need to fill in what you know here. You know that sine of 60, okay, you know sine of 30 degrees is a half. This one's going to be root 3 over 2. Cosine of 45, you know, that's root 2 over 2. Sine of 45 is also root 2 over 2. And cosine of 60 degrees, that's going to be 1/2. Now, anytime you forget one of these, you can always use your unit circle and go, okay, wait, 60 degrees. Here's 60. Root 3, this is 2, this is 1. Cosine is adjacent over hypotenuse, 1/2. Likewise with 45 degrees, I could have just drawn a 45, 45, 90, right? 45, 1, 1, square root of 2. So cosine is adjacent over hypotenuse, which is 1 over root 2, which translates to, after you multiply by root 2 over 2, root 2 over 2. And so lastly, what you do now, we're almost done, is multiply. Now remember, when you're multiplying fractions, the numerators get multiplied, the denominators get multiplied. So what we have is the square root of 6 over 4 plus, this is going to be 1 time, see the 1 right here? That gets multiplied by this number in front, which happens to be 1. So that's root 2 over 2 times 2, which is 4. Because I have the same denominator, I can even write it like this, root 6 plus root 2 all over 4. And this should equal sine of 105 degrees, which we also said was about 0.9659. So on your calculator, okay, you should, let's see here, don't save, you should check, all right? And so we're going to do that. So we're going to say root 6, and so we have root 6 plus and root 2. And let's see, enter. And I'm going to take that and divide that answer by 4. And I get approximately, what is that? It's supposed to be 0.9659. Check. Okay, so you can check on your calculator just to verify that you had the right answer, whatever. But that's what we're doing. These are proofs. So you're trying to make the left side equal to the right side. So the next thing we're going to do is we're going to try to find the exact value of cosine of 5 pi over 12. But we are going to use radians. So a little bit different than degrees. I'm not saying that you can't transfer this into a degree first, right? 12 goes into 180, 15 times, and 15 times 5 is 75. And then say, well, 75 is going to be 45 plus 30. Okay, so I know what my angles are going to be. I could do that. Try to do this in radians. So think about it like this. 5 pi over 12. What's going to add up to be 5? Okay, so it'll be something over 12, right? Over 12. It'll probably be a plus or minus. Let's try a plus. What if I said it was 3 pi over 12 plus 2 pi over 12? That's 5 pi over 12. But do I know these values as exact values, right? Is this right? Cosine of, let's see, pi over 4 plus pi over 6, right? And I do know those, right? Pi over 4 is 45 degrees, and pi over 6 goes into 180 30 times. That's my 30. So actually, I did this, right, without having to transfer to a degree. We just did this by adding. Okay, so now we're going to expand, all right? So let's expand. Cosine goes cosine, cosine. So cosine pi over 4, cosine pi over 6. Now remember, the signs are different. If this is a plus, this now is a minus. And then we have sine. So sine of pi over 4 times sine of pi over 6. So let's think about this. Pi over 4, cosine of pi over 4 is cosine of 45 degrees. That's root 2 over 2. Cosine of pi over 6, that's 30 degrees. Cosine of 30 degrees is root 3 over 2. Minus sine of pi over 4, that's root 2 over 2. And this is sine of pi over 6. Now, sine of pi over 6 goes into 180 30 times. Sine of 30 is 1/2. So simplifying this, we get square root of 6 over 4 minus the square root of 2 over 4, which is equal to the square root of 6 minus the square root of 2 all over 4. And so therefore, that's my answer. Okay, you're done. You don't have to do any more of that other than check to see if that equals cosine of 5 pi over 12. So does that equal cosine of 5 pi over 12? So if on my calculator, I can check that and I can go to cosine. So I'm going to go cosine and I'm going to say 5 pi. Where's pi? There's pi. So 5 pi divided by 12. And what does that equal? I don't know. 0.9997. So cosine of 5 pi over 12 is approximately, oops, let me fix that. It's approximately point. Oh, that's not right. And let me tell you why it's not right. Guess what I did? I did the thing that I told you exactly not to do. Look, guess what I'm in? I'm in radians, and my calculator is in degrees. So that's almost a big mistake. So I have to go to my calculator and actually change that into radians. So I've got to go to settings, okay? And in doing that, I go to document settings, and it looks like this. I don't know if you can see this or not, but you go to document settings and notice that I'm in degrees right now. I don't know if I could, is that right? Can you see that? Okay, so I'm in degrees right now. So I have to actually change that from degrees to radians. Okay, enter. And then go to, oh, for heaven's sakes. There we go. Up. Anyway, that's not working. All right. Anyway, and so checking that, let's see. I think I get cosine of 5 pi over 12, and that's going to be 0.2588 is approximately the same value as 0.2588. Cool. Okay, so you got to check your work to make sure that you have the right answers. Okay, and then what was the other one? That was 0.9. Yeah, that was also right. Okay, so find the exact value of cosine of 15 degrees. So I'm back to degrees. So if you changed your calculator, okay, to radians, you need to change it back. And don't forget, try to make it the default, because if you make it a default, okay, then it'll always be in one mode. It'll either be in always in degrees, always in radians. And so you'll know that you'll have to change it if, you switch the modes. But that's better than changing it or checking every single time. So cosine of 15 degrees is going to be, I'm going to say, I'm just going to use 45 degrees minus 30. Do you see that? I could have said 60 minus 45 too. Do you see that there's like a lot of options that you can use, but I'm just going to use this one. And in doing that, this is going to expand into be cosine cosine. So cosine of 45 degrees, cosine of 30 minus here becomes plus, and then it'll be sine of 45, sine of 30. Okay, and so cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2 plus sine of 45. So that'll be root 2 over 2. And sine of 30 is 1/2. So we get the square root of 6 over 4 plus the square root of 2 over 4. So we have the square root of 6 plus the square root of 2 all over 4. And that should equal cosine of 15 degrees. And for this one, cosine of 15 degrees, I have to use my calculator again. I get, what do I get? I don't have that one. So let me check it. Go to calculator. Okay. And I'm going to type in cosine of 15 degrees first. And I'm going to get 0.9659. Okay. 0.9659. And I feel like that was something that I already got. And the reason is because it's a cofunction. That's why we got the same answer. Okay, anyway. And this is going to equal root 6. So you have to do that. So you're going to go root 6. So root 6 over plus root 2. And actually, I'm going to put these in quantities because there we go. Because then I can divide by 4 and get an approximate 96.9659. I'm going to show you just so you believe me, maybe. Can you see that? Okay, so you just have to check. There you go. I think that's good. Anyway, you just have to check. But anyway, that's going to be 0.9659, which we just proved that. And I mean, you're not discovering anything new because these are proofs and you know what the answer is going to be. You're just checking to see and proving that you could do it. Okay. Now, this one is tangent. Let's do a tangent one. So to make 7 pi over 12, that's going to be tangent of what plus what. And I always tend to do 4 pi over 12 because I know that that's pi over 3. Plus, and 4, 5, 6, 7, we're going to go with 3 pi over 12. So that makes 7 pi over 12. Now I'm going to reduce this. So I've got tangent of pi over 3 plus pi over 4. Okay. Yeah. And we know both of those. Those are both the exact values. So let's expand that. So tangent, remember, goes tangent of A. So tangent of pi over 3, sign is the same. So plus tangent of pi over 4. And this is divided by 1 minus tangent of pi over 3 times tangent of pi over 4. Okay, for this, pi over 3 goes into 180 60 times. So we know that's 60 degrees. We know that for a 60-degree angle, across from 60 is root 3. Across from the 90 is 2. Across from the 30 is 1. So tangent is opposite over adjacent. So this value right here is root 3. So we have root 3 plus, and then tangent of pi over 4, right? That's a 45, 45, 90. So that's 1, 1, square root of 2. So that's 1 over 1. So that's 1. All over, and this is going to be 1 minus tangent of pi over 3. Well, we just did that. That's root 3. Times, it's a product, times 1. So that's just 1. So my final answer is actually root 3 plus 1 over 1 minus the square root of 3. Do not even think about canceling those root 3's or the 1's. You guys cannot do that. This here is a quantity. Don't break into that. That is a quantity. Don't break into that. And checking your answer for tangent, let's see. I get that. The only other thing is that I can think of is that you might not want to leave a root on the denominator. So if I didn't want to leave a root on the denominator, let's just say, just for fun, because math is fun, let's just say I'm going to show you how to get rid of that root. So we're going to go root 3 plus 1 over 1 minus the square root of 3. Let's just get rid of this just in case your teacher says, hey, rationalize the denominator. Have you ever heard that before? No. So in order to get rid of the root on the denominator, let's multiply by its conjugate, and that's going to be 1 plus the square root of 3. But remember, you can't change the problem, right? So what you would be doing is you would just be manipulating it or multiplying it by 1 so that you can get rid of the denominator. Okay, so let's do this. Root 3 times 1, that's root 3. Root 3 times root 3 is 3, so plus 3. 1 times 1, so that's plus 1. And 1 times root 3 is plus root 3. So it looks like on the numerator, I have 1 root 3 plus 1 root 3, and that's going to be 2 root 3. And 3 plus 1 is 4, so plus 4. On the denominator now, I'm going to go 1 times 1, which is 1. 1 times root 3, which is root 3, right? And then negative root 3 times 1 is negative root 3. And this is exactly why we multiplied by its conjugate, so those cancel out. And then negative root 3 times positive root 3 is negative root 9. Square negative out front. So that's going to be negative 3. So I have 1 minus 3. Well, 1 minus 3 is negative 2. And what this is this denominator goes for both of those. So this really says is 2 root 3 divided by negative 2 plus 4 divided by negative 2. And what that equals finally is negative root 3 minus 2. And so that would actually be my answer. So when I check tangent of 7 pi over 12, I could have, of course, checked my answer with what I got here. But even better is to check your answer with this one right here, because that's just a little bit more reduced. And if I were to just check that, I would go negative the square root of 3 minus 2. Enter. Oh. Negative 3.7. So you get approximately negative 3.72. And if I were to take tangent, tangent of 7 pi, so I'm going to go parenthesis 7 pi, divided by 12. I have different. Okay. And so I don't know what I got. I have to check it. It's not working. Anyway, so double check your answer. Okay, definitely. All right, so the next thing that we're going to do is, this is working backwards. So this is way easier. And just looking at this, ask yourself, which of the sum and difference formulas uses sine, cosine? Sine. So you're trying to figure out what was the question, kind of like Jeopardy. So what was the question? So you'd say, well, this question was sine of 37. If it's sine, then this is plus, right? And sine goes sine, cosine. So 37 plus 22. Well, 37 plus 22 is, what is that? 59. Okay. So my actual question was sine of 59 degrees. And so that was the question. This one is saying, well, let's see, which one uses cosine, cosine? cosine. So you would say, well, this question was cosine, parenthesis, of 83, because this is plus, then it'd be minus here, 53. Well, what's 83 minus 53? That's 30. So this becomes cosine of 30 degrees, which, of course, because you're trying to simplify as much as you can, cosine of 30 degrees is actually root 3 over 2. So that would be my final answer for this problem. And lastly, what was the question for this? And by the way, not sure, depending on the question, do they want this? Do they want that? Put both. Tangent, this one's obvious. So we have tangent. Now, because remember it's plus here, this will be a positive. So we're going to go 20 plus 32. So that's going to be tangent of 52 degrees. So that was the original question. Okay, so hey, I hope that helped you, and thanks for watching.